of America, and today we are interviewing citizens from different regions. Over to Lizzie with our first person.
Meet Cameron and Adam of Francium. She is from the S Block region of the PTA. Tell us a little bit about yourself.
I am an alkali metal, a member of Group 1. I have a large atomic radius and a high nuclear charge. I also have a low ionization energy, electron affinity, and electronegativity. I have lots of shielding.
Next up is Jane, an atom of gallium. She is from the P Block region of the PTA. Will you tell us about yourself?
I am a member of Group 13. I have a relatively small atomic radius and lower nuclear charge. I also have relatively high ionization energy, electron affinity, and electronegativity. I have moderate to low shielding.
Here's another element. Her name is Mia. She is an atom of fluorine, and she is from the P Block region of the PTA. Can you tell us about yourself, Mia?
I am a halogen, and I am a member of Group 17. I have a small atomic radius and a high nuclear charge. I have a very high ionization energy, electron affinity, and electronegativity. I have very low shielding. Finally, we have one last element. Her name is Lizzie, and she is an atom of neon. She is also from the P Block region of the PTA. Tell us about yourself, Lizzie.
I am a member of Group 18, the noble gases. I have a very small atomic radius and a high nuclear charge. I have an extremely high ionization energy. I have no electron affinity and no electronegativity. I have extremely low shielding as well. I do not bond with anyone. Here we have a map of the PTA, and circled here are the regions from which these elements that we have interviewed have come from. Cameron, an atom of francium, comes from the lower left region of the PTA, and her region is circled in blue. Jane, an atom of gallium, comes from the middle to right region of the PTA, and her exact region is circled in green. Fluorine and neon, Mia and Lizzie, come from the upper right corner region of the PTA, and their regions are circled in purple and pink. However, Lizzie comes from a farther right region than Mia does. We learned from the interviews that Cameron had a large atomic radius, Jane had a somewhat small atomic radius, Mia had a small atomic radius, and Lizzie had a very small atomic radius. If we line them all up, we can see the difference. Cameron has the largest atomic radius, and Lizzie has the smallest atomic radius. From the information we obtained from our interviews, we can conclude that atomic radius decreases across the periodic table of America, and atomic radius increases down the periodic table of America. Atomic radius decreases across periods because as electrons are added, they are pulled closer to the nucleus, which shrinks the electron cloud. Radius increases down groups because as energy levels are added, the electron cloud expands. Ionization energy is the energy needed to remove electrons from an atom. We learned from the interviews that Cameron has a very low ionization energy, Jane has a fairly high ionization energy, Mia has a very high ionization energy, and Lizzie has an extremely high ionization energy. From the information we obtained from the interviews, we can conclude that ionization energy increases across the periodic table of America, and ionization energy decreases down the periodic table of America. During the interviews, the guests mentioned information about their atomic radius, shielding, and nuclear charge. These three things affect their ionization energy. We know what atomic radius is, so let's look at the other two factors. Shielding is caused by inner shell electrons in an atom. These electrons block the attraction, or rather, shield the attraction, between the valence electrons and the nucleus. This makes it easier for electrons to be removed. Nuclear charge is caused by the number of protons in the nucleus. The more protons there are in the nucleus of an atom, the higher the nuclear charge. The higher the nuclear charge, the more attraction there is between valence electrons and the nucleus. The higher the nuclear charge, the harder it is for electrons to be removed from an atom. Atomic radius decreases across periods, causing ionization energy to increase across periods. The smaller the atomic radius, the closer the electrons are to the nucleus, and the harder they are to remove. Atomic radius also increases down groups, causing the ionization energy to decrease down groups. Electrons are farther from the nucleus and easier to remove if the atomic radius is larger. Nuclear charge increases across periods, causing ionization energy to also increase across periods. Electrons are held more tightly to the nucleus if nuclear charge is greater, making it harder for them to be removed. Lastly, shielding increases down groups, causing ionization energy to decrease down groups. If shielding is greater, electrons are held less tightly to the nucleus, making it easier for them to be removed.
Electron affinity is the energy change that occurs when an electron is acquired by a neutral atom. It is measured in kilojoules per mole. We learned from the interviews that Cameron had a low electron affinity, Jane had a somewhat high electron affinity, Mia had a very high electron affinity, and Lizzie had no electron affinity, which is an exception. Because noble gases are so stable, they have no desire to gain any electrons, meaning that they have an electron affinity of 0. From the information obtained from the interviews, we can conclude that electron affinity increases across the periodic table of America and decreases down groups. Electron affinity increases across periods because atomic radius decreases, which means electrons are closer to the nucleus and another electron is easily added. Also, the increasing nuclear charge across periods means that an electron is more affected by its attraction to the nucleus and requires less energy to add, thus increasing electron affinity. Electron affinity decreases down groups because the atomic radius increases, which means electrons are farther from the nucleus and another electron is harder to add. Also, the increase in shielding effect down groups means that an electron is not as affected by its attraction to the nucleus and requires more energy to add, which decreases electron affinity. Electronegativity is a measure of the ability of an atom in a chemical compound to attract electrons from another atom in the compound. We learned from the interviews that Cameron had a low electronegativity, Jane had a somewhat high electronegativity, Mia had a very high electronegativity, and Lizzie had no electronegativity, which is an exception. Neon is a noble gas that does not form bonds, which means it has no electronegativity value. It is also important to note that Mia, an atom of fluorine, has an electronegativity of 4, which was arbitrarily chosen as the basis for all other electronegativity values. Fluorine is the most electronegative element. From the information obtained from the interviews, we can conclude that electronegativity increases across the periodic table of America and decreases down groups. Electronegativity increases across periods because atomic radius decreases, which means electrons are closer to the nucleus and attract electrons easily. Also, the increasing nuclear charge across periods means that an electron is more affected by its attraction to the nucleus and tends to be located closer to that atom's nucleus when compared to the distance between an electron and nucleus of a less electronegative element. Electronegativity decreases down groups because the atomic radius increases, which means electrons are farther from the nucleus and do not attract electrons easily. Also, the increase in shielding effect down groups means that an electron is not as affected by its attraction to the nucleus and tends to be located farther from the atom's nucleus when compared to the distance between an electron and nucleus of a more electronegative element.
Atomic radius decreases across the periodic table of America and increases down the periodic table of America. And electronegativity, electron affinity, and ionization energy increase across the periodic table of America and decrease down the periodic table of America.